After this lesson, students will be able to find the slope of a line by looking at a graph or from knowing 2 points on the line. Do now, what is the rate of change or slope of the data below, and what does the rate of change represent? Pause the movie and try this problem on your own. Resume when you're ready. This table shows the cost of renting a computer and shows the rental charge given the number of days that you rent the computer. To find the rate of change, or slope, we need to find the rise and the run and compare the two, where rise is the change in the y-coordinates or outputs, and run is the change in the x-coordinates or inputs. Now rise, we start over here, 60 to 75, we're adding 15, 75 to 90, we're adding 15, 90 to 105, we're adding 15, and finally 105 to 120, we're adding 15. The number of days is going up by 1. So our slope, or rise over run, is 15 over 1, or 15. Now, what does the rate of change represent? In the context of this question, it means that you pay $15 more for each additional day of renting a computer. You pay $15 more for each additional day renting the computer. As we mentioned, slope is rise over run. It is a rate of change. More specifically, it is the rate at which the line rises or falls compared to the rate at which the line changes from left to right. Therefore, we're comparing our vertical change, or rise, the change in the y-coordinates, over our horizontal change, or run, which is the change in the x-coordinates. Now you'll notice that if these are the two ordered pairs, x comma y, you'll see that they have these little subscripts next to them, a small number lower than the variable, like 1 or 2. All this is a notation to help you to distinguish between the 2 points and to help you know which x-coordinate goes with which y-coordinate. Now, a positive slope looks like you're climbing a hill from left to right. So the slope of this line is positive. A negative slope looks like you're going down a hill from left to right. So this slope is negative. Slope is rise over run. So if you look at a line, you can pick any 2 points and determine how much you need to rise and how much you need to run in order to get to the other point. And then you may need to reduce the fraction. But regardless of which 2 points you choose on the line, you should get the same slope. Now, a quick comment that for the rise, when you go up to get to another point, that would be a positive number. And when you go down to get to another point, that would be a negative number. For your run, we're moving left and right. So if you're running to the left, that would be a negative number. And if you're running to the right, that would be a positive number. So to find the slope of this line, let's start with these 2 points right here. I can rise 2 points and run 1 point. So my slope, which we use the variable m to describe, is 2 over 1, or 2. Now notice how if I were to pick these 2 points, I should end up with the same answer. So our rise, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And our run, 1, 2, 3, 4, 5, 6 also reduces to 2. So the slope of this line is 2. Notice how if I were to start from this point and go to this point, I should still get the same answer. We just need to be careful when it comes to the negative numbers. So to show you, I would actually be running -1 because I'm moving to the left and our run is in our denominator, and our rise would be -2 because we're going down. -2 over -1 is still +2. Now you try. Pause the movie to find the slope of this line on your own and resume when you're ready. For this line, we can start with these 2 points. Our rise is 2 and our run is 3. 2/3 cannot be reduced, so the slope of our line is 2/3. We can also double check by choosing 2 other points and seeing if we also get 2/3. 1, 2, 3, 4, 5, 6, 7, 8 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 8/12 reduces to 2/3, so the slope of our line is 2/3. Notice how this number is also positive, which is consistent with the fact that our graph looks like we're going up a hill from left to right. Now try to find the slope of this line. Pause the movie and resume when you're ready. For this line, we have a rise of -1, 2, 3 because we're going down 3, and then our run is +1. So -3 over 1 is -3. We can double check with 2 other points. 1, 2, 3, 4, 5, 6, 7, 8, 9. So -9 over 1, 2, 3. -9/3 equals -3. Notice how our slope is negative, which is consistent with the fact that our line is going downhill from left to right. Now try this one on your own, pause the movie, and resume when you're ready. So let's say we choose these 2 points. Our rise is -1, 2, and our run is 1, 2, 3, 4, 5. -2/5 is the slope of this line. And again, it is a negative number, and our line does look like we're going downhill from left to right. What is the slope of each section of the ski lift? Pause the movie and try this problem on your own. Resume when you're ready. So for this first section, we're starting at 10 and rising to 40 when you look at your y coordinates. This is a rise of 30. We're also going from 0 to 20 for our run, so 30 over 20 reduces to 3/2. So the slope of this section is 3/2. Now to get from point A to point B, we're going from 40 to 50 for our rise, which is a change of 10. And then our run is going from 20 to 50, which is a run of 30. And so the slope is 1/3. From B to C, our rise goes from 50 to 90, which is a change of 40, and our run goes from 50 to 80, which is a change of 30. So our slope is 4/3. And finally, to get from point C to point D, we're going from 90 to 100, which is a rise of 10, and we're going from 80 to 110, which is a change of 30, and so our slope is 1/3. Notice how for 3/2 and 4/3 we have improper fractions that we left as is and did not change them to mixed numbers. This is because we want to leave our slope in the form rise over run, so improper fractions are actually preferable. We can also find the slope by using the formula m equals y2 minus y1 over x2 minus x1, as long as we know two ordered pairs that fall on the line. So for example, in this first graph, we know the points 3, 4 and -2, 1 fall on the line. So we can label these as xy coordinates. You can choose which ordered pair you want to be ordered pair number 1 and which pair you want to be ordered pair number 2. It will not make a difference in the end, but make sure that if you choose x1, for example, right here, that this is y1. The ones must go together. And then over here I'd have x2 and y2. Now our equation, m equals y2 minus y1 over x2 minus x1. Ooh. Let's erase this. So now we can just plug in the points. y2 is 4 minus y1, which is 1. And then x2, which is 3, minus x1, which is -2, and 3 minus -2 would be 3 plus 2. And then we can go ahead and simplify to get 3 over 5. So we found that the slope of this line is 3 over 5. If we were to use the strategy we were using before, we could start from this point and go up 1, 2, 3, our rise of 3, and run 5, 1, 2, 3, 4, 5. So the formula did get us a slope that is consistent with the method we were using before. Now you try number 2 on your own. Pause the movie and resume when you're ready. So we begin by labeling each ordered pair as x and y coordinates, and you can choose which one you want to be ordered pair number 1 and ordered pair number 2. It will not matter in the end. So let's say I make these 1s and these 2s. Our formula, m equals y2 minus y1 over x2 minus x1. And then we just plug in those points. y2 is 1 minus y1, which is 2, over x2, which is 3, minus x1, -3, so I can change this to plus 3, and I get -1 over 6. So the slope is -1/6, and you can see from our picture that we are going downhill from left to right. It is negative, and if I were to double check, I'd be rising -1 because we're going down 1 and running 6. 1, 2, 3, 4, 5, 6. Now the reason the formula is especially helpful is because many times you will not be given the graph, and therefore it's more efficient to use the formula if you're just given 2 points. So for example, find the slope of a line that crosses through 4, 4 and 6, 8. Well, we know our 2 points, so we can label them as x, y, and then we can distinguish which ordered pairs go together. So I've got my first ordered pair and my second ordered pair. And then we use our formula, m equals y2, let's fix that. M equals y2 minus y1 over x2 minus x1. So our slope is 8 minus 4 over 6 minus 4, which is 4/2, or 2. So we found the slope to be 2. Now you try the next two questions on your own. Pause the movie and resume when you're ready. We begin by labeling our x and y coordinates and choosing which one is going to be our first ordered pair and which is our second ordered pair. And then we use our formula, y2 minus y1, so 6 minus 10, over x2 minus x1, 7 minus 1. This gives us negative 4 over 6, or negative 2/3. So our slope is negative 2/3. Finally, number 3. y2 minus y1 is 12 minus 15 over x2 minus x1, which is 8 minus 14. This gives us negative 3 over negative 6. The negatives cancel out to give us a positive answer, and 3/6 reduces to 1/2. So the slope is positive 1/2. Now, let's try to determine the slope of a horizontal line. Say we pick these 2 points and we try to do our rise over our run. Well, our rise to get from this point to this point is 0. Our run would be 1, 2, 3, 4. Therefore, 0 over 4 reduces to 0. So the slope of a horizontal line is always equal to 0. Now the slope of a vertical line is actually undefined. So if you're ever asked for the slope of a vertical line, you would actually write down the word undefined. The slope is not 0. Here is why. Let's take a look at, let's say, these 2 points. Our slope, we know, is always rise over run. Well, our rise is 2, but our run is 0. And as you know, we cannot divide numbers by 0. We cannot have 0 in the denominator, or we get an answer that is undefined. And therefore, the slope of all vertical lines is undefined. Now, one way that I remember this, other than going and choosing 2 points on the line to remind myself when our denominator will be 0, is that if you think of this as the ground, you can walk along the ground quite comfortably. There's a slope of 0. But if you think about this as a wall, you cannot climb a wall, and therefore it is undefined. So in summary, a line with a positive slope slants upward from left to right as if you're going up a hill. A line with a negative slope slants downward from left to right as if you're going down a hill. A line with a slope of 0 is horizontal, and a line with an undefined slope is vertical. We also talked about the formula m equals y2 minus y1 over x2 minus x1.